So we were seeing about LNAs in the last class, and two different configuration of LNAs are available. So we'll come to see that and finish this unit with that. So single-ended LNA. So the configuration looks like a differential LNA, but output is taken only from the one drain of the transistor. So this is single-ended LNA. If it is differential, means we will be taking output V out, one lead will be here, and one lead will be from this transistor. So plus of V out will be here, minus of V out will be here. But since it is a single-ended LNA, plus of V out will be in one drain of one transistor and negative will be grounded. So this is a single-ended LNA. And what other components we have seen, it is only for the biasing and the output circuitry. Otherwise, it is looking like a conventional transistor circuit where we are going to have two transistors connected back to back. And I'm going to ensure that these amplifiers are going to provide the necessary amplification and rejection of noise. So the cascading M2 transistor is used to reduce the interaction of tuned circuit with the input tuned circuit. So in the output side, you have an LDCL tuned circuit. At the input side, you have an LGCB tuned circuit. So this M2 will ensure that both are isolated. Okay, so these two tuned circuits don't interfere, and M2 will ensure that both are going to be isolated. And this M2 will resonate with this frequency LDCL, and it will increase the gain with the center frequency. So it will also provide the necessary filtering, because in a tank circuit it will work on one particular frequency. So that particular frequency is heavily amplified. The other frequencies around that particular frequency is going to be rejected. So that is going to be carried out by this LDCL combination. And in M3, if you see, M3 is just like current mirror, we know. So M3, M1 form a current mirror. So the current flowing through M3 is going to be the same current flowing through M1. So mirror, it is going to have the same current. The current through M3 is set by the reference voltage. R reference this resistor and VDD will ensure what current is flowing through M3. So that is mirrored into the bias resistor and it is given to the gate of M1. So the current flowing through M3 and M1 are going to be same. So that is why they are called as the current mirrors. The resistance R bias is chosen in such a way that the value of noise can be reduced. Already in gate current is going to be very, very small in MOSFET. And because of adding resistance, the noise and thermal noise, other noises will increase. So we choose the value of R bias in a larger way so that these noise can be completely eliminated. So typical value is 2 kilo ohm. So by designing a R bias at 2 kilo ohm, they say that the noise can be minimized. And CB is the blocking capacitor, so which will ensure that any DC voltage coming from Vin will be blocked and it will not enter your transistor M1. And the value of capacitor CB is chosen as 10 picofarad. So that at the frequency of operation, it is just going to behave like a short circuit. So it is sometimes implemented as an off-chip component depending on the value. So this much low value of capacitance is very difficult to have an on-chip component. And sometimes this 10 picofarad can be implemented as an off-chip component. And how to realize the single-ended LNA. You can use many structures available. So the planar spiral, if you use that method, it will consume more die area, and that would than the conventional design. So the lossiness would also degrade the noise figure. So if the die area is going to be more, the power consumed is going to be more, and noise figure is also going to be degraded. So we have to compromise between planar spiral and a bond wire, so which is going to give me an economical area as well as a less noise, because LNA has a very important job to filter out noise. So if we don't meet that, then there is no purpose of designing this LNA. So alternatively, a bond wire and an external inductor can be used to to fabricate the parts of LNA. So if packaging is possible, then you can repeat that to produce bulk production of this single-ended